Floating point is a method of storing decimalized numbers. So we have a decimal place, therefore we can't store this in our normal binary methods that we've learned so far. So we need to store this float, as we call it in programming, into a floating point binary number. So in the exam you'll get told how many bits you have for this thing called a mantissa and how many bits you have for this thing called an exponent. And we'll look at those in a little bit more detail in a second. So first things first is you need to work out, put our decimal place in. Everything to the right of the decimal place works on a fractional basis. So we have a half first of all. Then we have a quarter. Then we have an eighth. Then we have a 16th. Then we have a 32th. And it just keeps going up. We can see the similar numbers, look, 2, 4, 8, 16, 32. We've seen those numbers before, so we kind of know the pattern that's going to appear. To the left of the binary point, everything works as it has done previously. 1, 2, 4, 8, going up. So our decimal point is a place where our fractions are on the right, our whole numbers on the left. We need to make 1.75. So we'll make 1 first of all. So a 1 there. So I've put a 1 at the beginning. Then I have my decimal place. And now I need to make 0.75. So if I think about what my fractions are in a decimal form, a half is 0.5, a quarter is 0.25. Added those together, I would get 0.75. So I need a half and I need a quarter. I was making a positive number, so I need to put a 0 at the front of my answer. The next step is to say I need to move this binary point to be before the first one. So I need to move it to here. So I'm going to write out my number again, 0.111. So I've moved this binary point 1 place. So this is almost my mantissa done. I then just need to get rid of the binary point, so 0, 1, 1, 1. I had, if we look back at the beginning, 5 bits for my mantissa. Currently my mantissa is only 4 bits. So I pad my number on the right hand side. So that now is my mantissa done. I now need to care about the exponent. The exponent tells it how far I moved the binary point. In this example, I moved the binary point 1 place to get it in front of that first one. Therefore, I need to put 1 in binary. I got given 4 bits for my answer, and I've only used 1 so far, so therefore I've got no 2s, no 4s, and no 8s. So I've padded it out. So now you can see that my exponent is complete. So mantissa, pad it towards the middle, exponent, pad it towards the middle. So this is my final answer, 0, 1, 1, 1, 0, 0, 0, 0, 1. That's that. If I was making minus 1.75, everything is exactly the same as what I've just done here. The only difference is we have to flip and add 1 to our mantissa. So we'll do that now, 0, 1, 1, 1, 0. Flip it, 1, 0, 0, 0, 1, and add 1. Remember the shorten method? Look for my first 0, change it to a 1, everything to the right of it is a 0, everything to the left of it is what was there already. So this is now my mantissa for that one. My exponent has not changed at all, so it stays exactly the same. So again, it's exactly the same as the positive version, it's just before I write down my final answer, I have to flip and add 1 to this mantissa to get my new one. I can look at it and think, right, okay, so that started with a 0, so therefore that is a positive number. This started with a 1, therefore it's a negative number. So that's a quick check overall. So there's quite a few steps there, but mantissa and exponent, the exponent is how far the binary point moved, the mantissa is the original number.